in class. Let's move on. The average velocity. Now, we need to know that average velocity is different to velocity. They're two different things, because you'll see in a moment that velocity almost always means instant velocity. What is the velocity at this moment? And that's different to what was the average velocity. It's a little bit like speed. In terms of that, there's a difference between the instant speed and the average speed. So you're going on a journey. At some time, your speed might be 0. At another instant, your speed might be 60 kilometres an hour. Say you're travelling from home to school. You've had to stop at the roundabout. You've had to stop at the lights. And at that time, your speed was 0. But other times, you're travelling at 60 kilometres an hour. You might be travelling around the school in the school zone at 40 kilometres an hour. Your instantaneous speed is changing. Overall, we could talk about your average speed from home to school, where we would take your total distance and divide it by the time. And that would give me your average speed. Velocity is similar in that concept, except with velocity, we're now talking about change in displacement. The change in displacement. Not what is your displacement. Your displacement is school, but what was your change in displacement? Well, we'd need it with respect to some given point. Home might be the point, or the train station might be the point that we're measuring everything relative to. So velocity, average velocity, is the change in displacement divided by the change in time. Something I haven't mentioned is, because displacement has both magnitude, that just means size, and direction, plus or minus, then you must give it as a plus or a minus. You must give both the straight out displacement and the change in displacement as a plus or a minus, positive or negative, along with the size of it. Then likewise, the average velocity, it will also have magnitude, a size, and a direction. It'll be positive or negative. And if it's an application that we can say up or down, then we could, that would be our measure of our direction. So just be aware that displacement velocity has to have direction added to it, a plus or a minus. Instantaneous velocity, then that is something that we need our calculus to measure for us. And again, because it's velocity, obviously it'll have magnitude and it will have direction. So it'll be a plus or a minus. The direction is this plus or minus, and magnitude would be the size. Moving on. Distance. Now, distance is different to displacement. Distance measures how far a particle has moved. So your reading on your speedo of your car will tell you how far you've moved, and it basically has magnitude only. So we might talk about the distance you've travelled over a week. So you've gone from home to school, and let's say that's all you've done, but you came to school, you went home. You came to school, you went home. Came to school, you went home. In the end, if you started at home and finished at home, your displacement may be 0, but your distance is not 0. And so distance is a different concept to displacement. And we have to actually know the exact journey in order to be able to calculate distance. It measures how far the particle has moved, and it has no magnitude. We don't say if it was 10 k's to and from school and you did 20 k's a day, 4 days, that's 80 k's. We don't say it's a plus or a minus 80 k. We just say it's 80 kilometres over the whole week was the distance that you drove. It doesn't record direction. It's nothing to do with plus and minus. It's just always a positive number, and you start at 0 over the time frame that you're recording the distance. Now, that has implications then for speed, because speed is the total distance travelled divided by total time. Total distance, total time. Now, we know that distance only has magnitude. Just got that from definition 4. Time we only count as a positive. So average speed has magnitude only. Instantaneous speed. This is going to also rely on calculus, and it won't be any different to instantaneous velocity, except that we're going to take the absolute value of average velocity to get the speed. Instantaneous speed, that we'll want that as instantaneous velocity, not average. Instantaneous velocity, because they're the same magnitude. It's just that speed doesn't have any direction. So we take the plus minus away from our velocity instantaneous velocity calculation. Another thing you need to be aware of. So you also need to be aware that X now, and you may have seen it appear previously, it actually represents displacement. It's commonly the pronumeral used for displacement. However, when we're talking about velocity, we want to graph displacement on our vertical axis. So it looks unusual in that we have this, we will put an X here only because this is going to represent displacement, and actually our horizontal axis represents time. So I just need to point that out, just in case you think that this is looking wrong. It's just a whole nother use for the letter X. You'll also see change in is abbreviated to this symbol, which is just the capital form of delta, which is the 4th letter of the Greek alphabet. And we don't consider negative time. So we don't have an axis going on down here in the negative direction for time. We don't consider that. I'll stop the video there and talk about the rest in another video.